Assalamualaikum warahmatullahi wabarakatuh and greeting to everyone. Okay, my name is NoorFawazi bin Nuruddin from NJIIT University Technology Malaysia. So today I'm going to share one of our experience, okay, conducting lecture using the online platform during the pandemic COVID. Okay, so in line with that, so this is the title of my presentation, okay, computational simulation, an additional element for open-ended mechanical engineering laboratory in the era of COVID-19. Okay, so in mechanical engineering, so we have a physical laboratory course where students are required to conduct physical experiment. Okay, so this photo shows some of the facilities that need to be operated by the students. In other words, the students must involve physical experiment with all these facilities. So what happened? So close contact between among the student will happen since they need to use all the apparatus together, and then at the same time it is quite impossible for them to maintain or to practice physical distance unless we control the number of student in each group. Okay, so we know that. So recently, our nation, especially at University Technology Malaysia in Kuala Lumpur, so we are facing the third wave of COVID-19 pandemic. So based on our experience, okay, based on our previous experience during the first MCO, so we start looking or start developing a method on how we can change this physical experimental work into another form so that this course still continue, okay, and there is no need to postpone the lecture to another semester. Okay, so since this is a problem, so the main objective for this work is we are looking for a transformation to the existing conventional teaching and learning, okay, and then at the same time, since it is part of the requirement set up by the Board of Engineering, all experiment must be or must have open-ended element. So we try to define with the open-ended approach within this teaching strategy by having a computational simulation. So we refer this computational simulation as a computational simulation technology that will enhance the understanding of our student while they have to conduct experiment virtually. Okay, or in other words, they have to analyze the raw data. Okay, interpret the result. Okay, and then compare with the computational simulation. Okay, so we have stated three objectives of this work. The first one is to propose method for lab teaching and learning using online platform. Okay, so online platform is the only option that we have. Okay, since the student cannot enter the campus, so they have to do their or they have to continue their study for this course, okay, lab experiment using the online platform. Okay, and then at the same time, we try to embed the FEM computational simulation. So this is where the technology is used as part of the open-ended element. Okay, and then finally, we want to encourage the use of alternative computer simulation technology, especially during the COVID-19. Okay, so here is the framework, okay, on how the method or the approach is practiced in this teaching and learning. Okay, firstly, the student by using the online platform, okay, at UTM we use e-learning as our online platform. Okay, so we conducted a video lecture. Okay, so we show the student what kind of facilities or the experimental apparatus. So we explain the step in general. Okay, in general. Okay, and then at the same time, the general procedures, only the general procedures are provided. Okay, in the form of document. Okay, which is distributed to the student. Okay, So the next task is, okay, since the students are given only the general procedure, so they have to explain or they have to plan a detailed procedure how to conduct the experiment by analyzing the shown video. Okay, and at the same time, most of the lecturers, they provide some raw data. Okay, so this raw data is not the ideal one, so the error is within the data. Okay, so the task for the student is to analyze the data, identify the error, okay, so interpret the data. So by interpreting the data, the student can guess what is wrong, what is right with the data. So they will find ways on how to improve the experimental work so that the accuracy can be increased. So this is done in a group. Okay, so they have to set up a small group among themselves, maybe one team with 4 to 5 members. So again, they have to discuss the analysis data, okay, or the lab procedure using the online platform. Okay, and then the focus here is we try to embed the computational simulation technology in this lab experiment. Okay, so when they discuss the experimental work, so they will discuss some of the physical meaning, what kind of experiment they are working on. Okay, what kind of result they are looking at, okay, or what they are aiming at. Okay, and then at the same time, they will explore the data. So how the data are obtained. Okay, so from there, they will start exploring on how to adopt the procedures, okay, the physical procedures through computational simulation. Okay, so they will learn all these steps all by themselves. Okay, it's very simple computational simulation, but the most important thing is how they see the physical experiment or the physical meaning of the experimental work through the computational simulation. And then in the end, they will compare the computational result with the experimental result. So from there, they will interpret the data again, okay, and then they will enhance their conclusion, okay. So in the end, they will improve. They will propose or suggest procedure on how to improve the physical experiments. Okay, all these students, they are informed that the data, the raw data, not the ideal one. Okay, so there must be something wrong, and they have to find out what's is not correct, what is not the abnormality within the data. Okay, so so from the comparison between the physical experimental data and the computational simulation, so they will suggest, okay, any method on how to improve the experiment. So this is done from the group discussion. Okay, next. Okay, so here is an example, okay, how we conduct the simulation. Okay, so by using the online platform, students are shown the video, okay, the detailed experimental setup, okay, the computer, for example, okay, the computer, and then the apparatus are explained by our technician, okay, and how to conduct the experiment in general. Okay, so all the material, all the documented material are given using the online e-learning, which belong to University Technology Malaysia. So here is some of the general information on the experiment. It's very general, not detailed, because the student need to develop the detailed procedure. Okay, need to analyze the raw data, okay, tabulate the data, okay, and then interpret the data. Okay, so here is some of the step. Okay, so this is what we see, part of the open-ended element. Okay, and then at the same time, so we want to enhance this open-ended element. So since they did not conduct the experiment physically, so they need something to enhance their understanding. Okay, so what we do is, okay, so what we do, so we introduce the computational simulation. Okay, so as I mentioned in the previous slide, so they need to explain the experiment in detail, step by step. Okay, interpret the physical data, analyze the data, analyze the raw data. Okay, and then come up with the physical meaning. Okay, by understanding the physical meaning, so how can they represent the physical meaning through computational simulation. So this will enhance their understanding. Okay, as mentioned just now, so once they start comparing the computational simulation result and the experimental error, so that is the experimental result, so they will identify, okay, the abnormality or errors, okay, that are found in the experiment. So they will propose how can they improve the real physical experiment. Okay, so here is an example. Okay, example conducted in one of mechanical engineering lab. Okay, so the experiment is on stress distribution in a thick wall. Okay, of course, by using the online platform, the students are shown the experimental apparatus. Okay, and then the given data are all given. Okay, so once they interpret the data, analyze the data, tabulate the data, so they need to represent the physical meaning of the experiment or the physical, I mean, the result. Okay, but they need to show the physical meaning of the experimental result through computational simulation. So in this example, okay, so they are briefed to identify or to conduct experiment, okay, to search the strain property at different position, okay, at different location. Okay, so here this is the cross section of the thick cylinder. Okay, so basically for non-engineering student, it's hard for them to imagine, oh, how can they get the strain measure within this thick cylinder. So it's hard for them to imagine. So by having a computational simulation, so they can imagine, so the measurement is done across the thickness of the thick cylinder. So here is the step, okay, is the step when they are working with the computational simulation. So they have to model the cylinder exactly similar with the experimental apparatus. Okay, so this include the dimension. So they will start thinking about the dimension, the material property which they need to refer to certain standard, ISO standard. Okay, the elastic modulus, the density of the structure. Okay, and then the next step, they have to imagine that since this is on pressurized thick cylinder, so they have to include the pressure within the cylinder. So that's why there is a device, okay, in the experimental setup where they have to press some pressure into the thick cylinder. Okay, so in the simulation, so they define the pressure within the thick cylinder. So here they can see the relationship between the real experiment and computational simulation. Okay, so this is the usual step. So they have to match the structure. Okay, next. Okay, so once they completed the simulation, so they will compare the result, okay, from the experimental work, okay, and then at the same time, they can also compare with the computation, okay, from the theories that they learned during solid mechanics. So before they start working on this experiment, so it is compulsory for them to take lecture on solid mechanics, so they can compare the result, okay, and then at the same time, okay, since the computational simulation is embedded in this experimental work, so they can compare with the computational simulation. So in this example, the student use abacus, okay, abacus to get the simulation result. So three results are compared here. Okay, the experiment, the theoretical, okay, the theoretical computation, okay, the theory, the analytical computation that they learn during their conventional lecture, solid mechanics, okay, and then final element or the computational simulation using abacus. This is very open-ended because they have to explore the computational simulation on their own. Okay, it's very simple, but they can understand the physical meaning clearly. Okay, so by having this computational simulation, they will start thinking, so this is blue color, this is green color, so this is red color. So what are the different? Okay, so from the result, so they notice that the strain value are all in positive value. Okay, so that's why they got this color. Okay, in comparison to this one. Okay, so these are negative value. Okay, so from that they can conclude that there is a different or there is a variation of strain value, okay, from the very inside of the thickness of the cylinder to the outer surface of the the cylinder. So the comparison can be seen from this graph. So they can make a very good conclusions. Okay, and then at the same time they can see the relationship between the experimental work and the simulation. Okay, so here is another result. Okay, so the first one is a result based on the input pressure, okay, with 1000 psi. Okay, and then this is the second one for with input pressure 2000 psi. So basically from this comparison, so they can come up with very technical conclusion. Okay, so this is the target of our engineering education. So they want the student to see the relationship between what they learn during lecture, okay, and the real experiment. Okay, and then at the same time they compare with the computational simulation. Okay, computational simulation. Okay, by using this computational simulation, they can enhance their computations. Okay, so they can check the strain property at all position. Okay, and at the same time, they can explore. They can change the design of the cylinder. So they can change the material property of the cylinder. Okay, the thickness of the cylinder. So this will advance their understanding. So all these are explained during their brief session, okay, before they start working on this simulation, so that they can understand uh, uh, clearer, okay, and better. Okay, so we did conduct a feedback, okay, feedback on how they understand the content of the experiment. Okay, so the first question, okay, we ask the student whether they can see how the theory works for the real experiment. Okay, so from this result, okay, but even though they did not conduct the real physical experiment, but by using the online platform and the computational simulation, it seems that they can see how the theory works for real experimental work. Okay, how the theory works for real physical experiment. Okay, and then they found that this computational simulation is very interesting because they can modify the model, they can modify the material property. So and at the same time they will get different results. So from that different result, so they can feel the effect of the changing parameter to the distribution of the strain. So this is a very good teaching and learning approach. Okay, so, and very open ended, and at the same time it will enhance their understanding. Okay, so it is also found here, so the students are very confident, okay, to enhance their analysis. Okay, because this is a very simple simulation. Okay, very simple simulation, but it is validated with real experiment. Okay, next. Okay, sorry, next. Okay, okay. So this is the end of my presentation. So these are the three conclusions that we can. Okay, the three conclusion. The first one. Okay, so the approach motivate the students to explore any deformation. So any deformation or any strain distribution of structure or machine numerically. Okay, since they cannot conduct real physical experiments, so they can conduct the analysis or study the deformation or study the variation using numerical computational simulation technology. Okay, so this will enhance the understanding, especially during the time where they are unable to conduct physical experiment. Okay, and then lastly, the most important part, okay, since we have to satisfy the requirement of the Board of Engineering, the open-ended element is enhanced during the course, since they have to explore the detailed concept of mechanics, okay, the detailed concept of the mechanics in order to determine the input parameter for computational simulation. So that's all for my presentation. Thank you.